full screen.
Can you see and hear me now?
Shared. 1 second, sir. Just we are sharing it again. You okay? Okay, cursor is visible, right? Yeah. Yeah, okay. Yeah, presentation will share. Again, Prasad will give introduction, then he will start the presentation. Okay? Yeah, it will start from the beginning. Okay? Yeah, right. Yeah, right. Thank you.
अच्छा
Sir, can you unmute your speaker? Sir, please mute your speaker.
Oh, hello.
Sir, please mute your speaker. Please mute your speaker.
So your audio is not. Huh? Live streaming.
Can you mute your speaker, sir?
Microphone.
My need to be muted.
Yeah, Teams.
Okay,
Because
okay.
it is live now. Your voice is getting visible over.
एक और
Yeah, he's speaking.
I'll start now, sir. Right now I'll start again. Can you hear me now? Can you all hear me? Can you all hear me now? Thank you.
Yes, sir, we can hear you, but the only thing, a few people are trying to see it on the YouTube, but they are unable to see. I think I should ask them to leave.
But some of them could able to see that I received the snapshots of the YouTube streaming.
Okay. Fine, sir, I think we can go ahead. Dr. Prashant, we can go ahead. Whatever we can see, that will be better now.
Okay, fine.
Thank you. We can go ahead with your presentation.
Sure.
Okay, thank you.
Now, can you see the PPT now?
No, not yet. Only you are visible. Yeah, now it is visible. Now PPT is visible now. You put on your
Fine. Is it in the full
put it
screen
to
mode?
full screen mode, I think. You can put it to full screen mode. Yeah.
Yes. Has it come now to full screen mode?
No, not yet. Not yet. Full screen mode is not yet done. From your side only you have to do it, sir. Full screen.
Yeah, we did it from our side. It will take some.
Now I think you can put it to full screen, yes. Slideshow, you can put it to slideshow now.
Yes, it is in the slideshow only.
Is it coming, sir?
No.
అన్న స్లైడ్ అప్ డౌన్ చేయ ఒకసారి అప్ డౌన్ అవుతుంది కానీ మ్యాక్సిమం రివ్యూ అవుతలేదు మనకు అన్మ్యూట్ ఉంది కదా మ్యూట్ ఉంది
like PDF sharing, sir.
లేకపోతే రే ఫుల్ స్క్రీన్ లేకపోతే దాన్ని ఫుల్ విండో పెట్టేసి
Only you people are visible now, PPT is visible now.
Is it visible, sir?
Yes, yes, it is okay now. Perfectly okay. You can start with.
Fine, thank you, Javin. Fine, thank you, Javin.
I'm
Sorry for this.
muting myself. I'm muting myself. That's okay.
యా నౌ ఇట్స్ ఫైన్
Sorry for this interruption.
Please go ahead.
Sure. So as far as these services are concerned, I have explained earlier about we have started this operational service during 2016 of August 2016. There we have launched this services during the 21st NOSTCB meeting, and these services are being widely utilized during several scenarios, like during the real oil spill events and during the hypothetical oil spills, during marine mountains, and these services are also being used during the field experiments, and also during national and regional level pollution response exercise. It's also being widely used in the research academia. Here you can see we have carried out several case studies that were reported during 2006 to 17, that were reported along the Indian coast. By taking all the case studies, we have executed the oil spill trajectory prediction with the help of our operational model, and those predictions were compared with that of the observation. The observations are nothing but the oil slick signatures that are obtained from the satellite and also from the in situ reports. With the help of that, these simulations are validated, or I can say they are compared one to one, and the performance of the model is also evaluated during this course of research. Here you can see the various categories of users from Indian environmental consultants, Pollution Control Board, Ports and Maritime Board, and other oil spill responders are widely using our services. This is the agenda as far as this training session is concerned. The first one is a technical session wherein I will be explaining about this trajectory prediction setup with the help of some case studies, how we have set up the model for several regions. Those once after setting up the model, the trajectories were generated and they were validated with the term. I will be showing some cases, one or two. Then I will be telling about the consultancy services which we stakeholders. Then later I will be explaining about some field experiments. These field experiments were actually conducted to improve the performance of our modeling system, because the inputs of the model are all in the forecast mode, so they cannot be they cannot perform well all the time. The performance of our modeling system, we have conducted the field experiments. So from that we could able to know how good we are in predicting the oil drift pattern. And then I will be explaining about this, like the three-dimensional modeling of oil spills, and then this enhanced version of this online oil spill advisory system. I will be just briefing about the salient features of that system. Later I will be demonstrating online, like how to generate the oil drift patterns using our online oil spill advisory system. And here is the setup of the prediction validations. Here we have an oil spill trajectory model in its core, which is nothing but a genome. This genome model is adopted from NOVA, and it has been customized to the Indian Ocean, to the Indian Ocean scenario. As far as this diagnostic mode of setup is concerned, the user or the modeler has to set up his own scenario. It means he has to bring his own spatio-temporal winds and ocean currents and later the diffusions, the tidal currents, and then the wave interaction. So everything the user has to set up to generate the realistic oil drift pattern. Apart from that, you need to give the preliminary information such as what is the geographical location of the spill, and what is its date and time, how much pollutant is spilled, and what is its quantity and its type. So these preliminary information you have to feed into your modeling system. So then only it can deliver the oil spill trajectory. So once after getting the oil spill trajectory, it has to be validated with the signatures that are obtained from the SAR data, which is nothing but the synthetic aperture radar data that are from the radar missions. So for example, I can say NVSAT is no more now. Now you can use the Sentinel missions and then the radar sat, Cosmos Skyme. So there are several radar missions are there. With the help of that, actually we will be validating our simulated trajectories. So once after that, we will be able to know what is the separation distance between the prediction and the observed and the observation. So both the trajectories are both the drift patterns will be taken to a common platform, which is nothing but the ArcGIS, the Geographical Information System, wherein you can find the separation distance between the two. Then you will be able to judge the performance of the model. I can show you some case studies where we have compared the simulation and the observation. Apart from that, these are all the several activities that are being carried out under the roof of these oil spill modeling services. As far as the advisory task is concerned, our main role is to issue the oil drift pattern during the real-time oil spills. For example, I can say about this Ennore oil spill and the spill which occurred off Mauritius, and there was an wreckage of the recent one which I am saying is the vessel wrecked off a Sri Lankan coast, which is empty New Diamond vessel. It raised the fear of oil spills to the Sri Lankan coast and also to the Indian coast. So during that hypothetical scenarios, the user may not be knowing that whether the pollutant will reach our coast or not. So at that time, you can make use of the system and you can judge whether the pollutant will move towards the shore or away from the shore. And then during the marine mountains and also during the pollution response exercise. And as far as the operational task is concerned, we are always focused in maintaining and upgrading the system. You know, as far as the online systems are concerned, there will be several maintenance issues will be there. We have to, you have to, we'll be mainly focusing on rectifying the user need, and we'll also be upgrading the system as per the user need. So in the later slides, I can show you a sophisticated system where the user can interpret the oil drift patterns and they can take a decision on that. And as far as the research task is concerned, we will be carrying out several modeling activities, and then after carrying out the modeling, the results will be validated with the help of the synthetic aperture radar data. Especially we are using the radar mission because when compared to the optical missions, the radar missions are quite sophisticated, and they will also overcome the demerits of the optical missions like cloud cover, and it does not require any source of illumination since all the radar missions are carrying active sensors on board. So we can so we are always relying on this synthetic aperture radar data, and later those results will be communicated to the scientific journals, and also it will be published in the conference proceedings, so that a technical committee will be reviewing our results, and they will approve the results, and then it will be published in the scientific journals. Here I will show you only two case studies. One is the Mauritius oil spill and the other one is the Ennore oil spill. In this during this event, this actually happened during the 6th of August 2020. So actually the vessel which is shown here, it wrecked during 25th or 27th of July at this location as it got stuck in the coral reef. So for a course of time, it did not report any oil leak or it did not report any spill. But after 5th of August, the oil leak was noticed from the satellite data, and we also got the information from Mauritius Oceanographic Institute, and they have requested us to carry out the oil spill trajectory prediction. Based on their request, we have generated the oil drift patterns as shown here. In the left panel, you can see the satellite data on 3rd of August, where the vessel is seen here, but there was no oil leak detected from the vessel. But after that, after 6th of August, around 23 hours, I mean, that is during the night, the leak was detected as per the information from the Mauritius Oceanographic Institute. So we have taken those information, and the oil spill drift pattern was generated for that particular period. So here it was noticed the vessel was leaking continuously the pollutant, especially this fuel oil and the diesel oil were reported to be leaked. And for the entire period, the oil drift pattern was generated, and it was also compared with that of the satellite observation. Here you can see this is the satellite data obtained on 10th of August during 1835 hours. This one is the MV Vacatio vessel, which checked off this blue bay, and here you can see this is the coral reef. So as it got stuck in the coral reef, it started leaking the pollutant. And here you can see the dark patches that are the pollutants. So actually, it is it has reached the southwest coast of Mauritius, and it has affected a lot during that particular period of time. And in this right panel, you can see the simulation and the observation together. Both are compared in a common platform, that is the ArcGIS, in ArcGIS platform. This one is the oil slick signature that is obtained from this Sentinel-1 radar data. And these plots you are seeing the simulated drift pattern or the simulated oil particles that are generated from our simulation, and both are matching, both are well in agreement. And from this simulation and the observation, we have also noticed the southwest coast of Mauritius is highly affected due to this MV Vacatio vessel wreckage. And this one shows about the wreck of empty diamond vessel that caught fire off Sri Lanka. Actually, here you can see the location of the vessel here. This is the empty blue diamond vessel. Since it was around 30 nautical miles off the coast, but there was since it has got 70,000 metric tons of crude oil on board, and it has also got 1,700 metric tons of diesel oil on board. So it raises the fear of oil spill. And as per the request from the Sri Lankan Met Department, we have generated the scenario for this particular period of time. And during the simulations, we also noticed the change in the vessel's position, because during the response operations, I think you are also aware of that, because Indian Coast Guard was also involved in this response operations. The vessel was, sometimes it was towed away from the shore, and sometimes it was brought near to the shore based on the mid-ocean conditions. So as per the updated positions of the vessel, the drift patterns are generated, and here you can see that the oil drift pattern. From the oil drift pattern, you can see it is always moving away from the shore. So we have informed the Sri Lankan Met Department and also the Maldives government and the Indian coast also. We have informed that there won't be any threat of the pollutant. So as far as the mid-oceans are concerned, it is moving off the shore, and it is also moving away from the Sri Lankan coast. So this Maldives coast, Kerala coast and Sri Lankan coast were not under the threat of the pollutant reach. So we have carried out several hypothetical simulations. Even though there was not an major oil leak, there were some minor leaks were there, but it was well controlled by
the oil spill responders, especially the Sri Lankan Navy and Indian Coast Guard. They have contained it, and there was no major catastrophe reported. This is about the oil spill trajectory pattern simulation during the Ennore oil spill. This was quite known to all of us, since the collision between the two vessels occurred very near to the shore, and hardly it is 2 nautical miles from the Ennore port. So the drift pattern was towards the coast, and it was moving towards the southern. It was moving towards the southern Tamil Nadu coast. Here you can see the bulletin also here, where you can find the landmark and also the predicted length that is likely to get affected because of this pollutant leak. So these simulations are carried on nowcasting and the forecast basis. So nowcasting, in the sense, we'll be using the analyzed forcings, and as far as the forecasts are concerned, we'll be using the forecasted wind and ocean currents forcings. So with the help of different metocean parameters, these drift patterns were generated, and it was also compared with the satellite data also. Here, as far as the study is concerned, we have used the data from the Sentinel-1, wherein the zone of pollutants that has affected the coast was noticed from that, and those area was taken for the comparison, and it matched well with the agreement. I'm sorry that I forgot to include that. This is an old event, so I have not added this one, but which was accepted by the Journal of Gas System Science from the Springer nature. They have accepted our simulation, and they have also published our results. You can refer that in online also. And coming to this next section, this is about the consultancy services to benefit the stakeholders. Here you can see, suppose if you consider the hotspot like Gulf of Kutch and Gulf of Kampat, where there were several where these coasts are highly vulnerable to the oil spills due to the several port operations and SPM operations. During those moments, you can make use of this type of study. Like how you can, I'll just tell you how you can make out this study. You need to consider your region of interest. For example, here you can, here I have taken the location B as my region of interest. Here you can see a quadrilateral here, considering this as my region of interest. And if you are at the location A, and you need to spot out the particular location where the oil spill. You have to locate the zone which is highly prone to oil spills. Here I have taken this is an hypothetical location. This I have taken as a hypothetical spill location. So from this location, suppose if the accidental oil spill occurs, then you can monitor how it moves, whether it is moving towards the coast or away from the coast. And you can make out a chart like this, which is the seasonal chart, and it also gives the impact at your region of interest during the spring and the neap tide days. You can take the spring and neap tide days because as far as the gulfs are concerned, the tidal currents play a vital role, and the tidal range is also very high. If you consider the Gulf of Kutch, I guess it will be from 2 to 7 meters, and in Gulf of Kampat it will be more than that. As per a recent publication, it was near this Hazira port and then Bhavnagar area. The higher tidal heights around 11 meter was also reported. So as far as the zones of tidal currents are concerned, you can make out this study, and you can also estimate the period of impact from this chart. So what you need to do is you have to carry out the study for the entire year so that you can clearly identify the period of impact. And here in this study you can see during June and July there is no impact to this region of interest, but during this October and November the region is highly affected. So in this case, in this type, you can you can study the impact or the intensity of impact to your region of interest, and you can also take a decision based on this. As far as the field experiments are concerned, we used to conduct the field experiments to improve the model performance. Here I can show you one example. We have procured an SVP drifter, which is surface velocity profile drifter. We have procured this, and it was handed over to the Coast Guard of Western region. They have deployed this off Mumbai. Here you can see the track of the drifter, how it moved. These blue dots are showing the track, and it has also reported its position through the Argos satellite system, Argos satellite, where we will be getting the location from the Argos satellite system. After a period of time, the drag of the drifter got cut, and the speed of the drifter got considerably improved, and then it beached at the coast of BU. So what happened actually? This we cannot. These accidental cuts we cannot consider this. Whenever the drifter has reported its position in the periodic interval, we have taken those positions, and they are taken for the comparison. And here you can see this is the result that is obtained from the drifter experiment. This is the location where the drifter was deployed, and this blue line shows the drifter's track from the period of 2011-2006 to 2017-11-2006. Here you can see a systematic the systematic drift is noticed here, and after which the drift pattern was not regular, and those period was eliminated from the study, and only during this 20 to 27th of November 2016 the data was taken and it was used for the comparison. Here you can see there are different tracks. It's black colored and there's red colored one. There are different tracks that are generated from several ocean models. We have several ocean models here. HICOM is there, and then GODAS based form for Pune is there, and the ROMS model is also there. So the tracks were generated. The tracks were generated with the help of several models, and we have compared this with the actual path of the drifter. Here you can see the HICOM model. The track which is developed from the HICOM model matches almost with the drifter's track. Only there was an underestimation in the magnitude. Otherwise, it is quite in agreement with the drifter's track. So hence you can decide that this HICOM model is doing good in this situation. And next to that, this GODAS based on P1 it's also moving in the similar direction, but even an underestimation of magnitude was noted here. As far as the other currents are concerned, they are totally out of phase with this drifter's track. So from this experiment, we can say that the HICOM model and the GODAS based on P1 is performing well as far as this period is concerned. And these results were also published in the form of a technical report. It is available in the Ministry of Earth Sciences website also. And as far as this marine mocktails are concerned, I think you are aware of these things. We were also in touch with the Reliance Industries Limited. So they used to conduct this mocktail with the help of the rice husk, which is a non-marine pollutant. During these experiments, the oil drift pattern was also simulated, and we could able to track the movement of the rice husk. So after a period of time, here you can see the model was run during this period. Later, the observations were collected with the help of the Reliance industry officials, and those were taken for the comparison. In this one, in the right panel, you can see that this is the location of the spill, where they have spilled around 500 kilogram of rice husk here. Even though they have made the boom and all, it couldn't able to restrict the movement of the entire husk. Still, after a period of study, the husk has also reached the shore near this particular region. This red dot is showing the location where they have sighted the rise physically. And as far as our comparison is concerned, the simulation that is obtained from the HICOM model, this ocean current model, has performed well in this case. So we can take a decision based on these experiments. Now let me tell about the ongoing developments, especially on the three-dimensional coastal hydrodynamic flow modeling and also the three-dimensional oil spill modeling. Here you can see the setup of the flow model, wherein the temperature salinity module is included and turbulence model is also included. As far as the forcing is concerned, the wind is given here, and as far as the initial conditions are concerned, the surface elevation and then this U and V velocity and the settling velocity was given as the initial condition. And here you can see the water level was given as a boundary condition. In the sense, suppose if you are setting the model for a particular domain, you need to give the forcings as a boundary conditions, so that it can cover the entire region of study. I think this will be somewhat technical, so I don't want to explain much on this. Once after getting the drift pattern from this flow model, that will be given to the oil spill model, which is a three-dimensional model, wherein you have to feed the exact composition of the oil fractions, like how much heavy mass is there, how much volatile mass is there, and how much asphalt in mass, and you should also give the wax mass. Now, after giving all this information to this oil spill model, it will, based on the lighter and heavier density fractions, it will undergo the weathering process, wherein the evaporation and sedimentation are the major weathering processes. So those processes will be considered considered during the simulation, and after the simulation, the model will deliver the oil track, and it will also give the particle track mass budget along with the concentration. So this is actually an entirely three-dimensional model. These are all the governing equations, wherein the temperature salinity module and the turbulence module are included. As far as the oil spill model is concerned, it will compute the evaporation factor using these equations, and also the sedimentation based on the density of the lighter and heavier fractions. It will compute the rate of evaporation and the rate of sedimentation. You can see this is an typical experimental outcome, where the model was set up, the three-dimensional model was set up for the region of this Mahanadi river. Here you can see this is the Paradip port. So once after setting the model has computed the surface elevation that has been compared with the real-time tide gauge instrument. Here you can see the amplitude and phase of both the model and the observation. As far as the phase is concerned, the model matches well in agreement with that of the tide gauge. And as far as the amplitude is concerned, there was an underestimation and lower estimation was there, but still it could able to capture the signals exactly as far as the phase is concerned. So once after getting this phase agreement, the hydrodynamic currents were generated from the three-dimensional model. Here you can see the vertical profile also. In this picture, you can see the lowering of the current speed from the surface to the depth. So when you move towards the depth, there will be a reduction in the velocity of the currents. This is about the three-dimensional oil drift pattern, which is generated from this particular location, that is from 86.79 and 20.16. And this is this initial spill location, wherein you can see the drift pattern at several time steps. And this legend shows the coordinates of the oil particles at different depths. So, and as far as this graph is concerned, you can see the coordinates of several oil particles with the different colors. It represents the coordinates of the oil particles at different depths. And now coming to the other ongoing advancement in our oil spill advisory system, which is called as an version 4. As of now, we are using, we are using the version 3. In version 3, we plan to include the mass balance, the quantitative status of the pollutant, so that it will be an upgraded version when compared to version 3. As far as this version 4 is concerned, you can see the spatial representation of the drift pattern here. Here we have also stacked several layers here. Here we have executed a few hypothetical spill scenarios. One in the Gulf of Kutch, and the other one is the Gulf of Kambat. So once after the simulation, the drift pattern was taken to this JS platform, where you can see all other layers also, so that an oil spill responder can decide about their cleaning and response activities. If possible, I can show you a live demonstration also on this. But before that, you can see here the features of this system. That is the version 4. Here you can see the drift pattern from this picture. So these red dots are showing the position of the oil particles. When you click on a particular dot, it can show you the quantitative status of that. Like if you can see, if it is a solid circle, then it is telling that it is floating, and if it is a cross mark, then we can understand that it is the particle is beached, and if it is a hollow circle, we can tell the particle is evaporated. So this type of quantitative estimation is not there in the previous version, and now we are going to include this one. This is an experimental outcome after computing the quantitative status. And not only that, you can see several layers also stacked here. Here you can see our other services also, what we are doing on operational basis, potential fishing zone advisory, and the surface currents you can see here. And then you can also, if you check on this layer, you can see the sea surface temperature, chlorophyll, and then the GHz SST, which is obtained from the satellite. And apart from that, you can also see the landing centers, several landing centers that we are giving on operational basis. Several sectors also you can see, and the boundaries of the EEZ zone. You can also see the depth, which is the bathymetry. You can see all these features in a single platform. So this actually has been done exclusive on ArcGIS by my colleague. So he has plotted all this information in a single platform, so that this will be linked with the modeling system, so that everything will be automated in a single stage, so that the user, once after submitting his request, he can get all this information after the model completion. And this is one other scenario which was generated in the Gulf of Kambat. Here you can see again the same. If you click on a particular dot, you can see the spatio-temporal information of that latitude and longitude, what is the date and time, and what is the status of the particle, and how much mass is floating, how much is beached, and how much is evaporated. So everything will be on a single flight. So once after our entire automation, these services will be made available to all the users, so that they can take a better decision. And now I have come to the last session of this training program, which is nothing but the online oil spill advisory demonstration. I have taken few snapshots also, because sometimes if you face any connectivity issue, then you can also follow up with the help of this presentation. Here you can see about the online operationalization process. When the user enters into our system, he once after completing the registration, he can submit his own inputs, and he can trigger the model by himself. So there won't be any there won't be any other human interference. The user can directly submit his request. Once after his submission, the model will be triggered along with this wind and ocean current forcings. These wind and ocean current forcings that are obtained into our oil spill server on daily operational basis. So this will be pre-fed, and this will be pre-fed into our system so that the user can trigger the system at any time, and they can get the output like this. One will be in an animated format, the other will be in an open layers web map. And as far as the offline execution is concerned, this is the way how we are doing this offline execution. The offline execution includes the details of the spill again, and then wind forcing and ocean currents also. So those will be passed as an arguments to this executable file through a text file, and later it will create the spill and it will also run the spill. So once after that, you'll be getting the trajectory pattern in the form of an SCDF files. The SCDF files, they are not compatible for all the users. So what we'll do, we'll post process the SCDF files, and we'll be displaying the trajectory pattern as shown here. And here you can see these are all some snapshots which I have taken. What you can do is, once after entering into a system, you have to do a simple registration. Once after the registration, you can see your user information here. Here I have given my information. So you need to give only the preliminary details, like what is the type of the spill, whether it's a continuous or an instantaneous one. Continuous in the sense, we know that if the source is emitting the pollutant for a particular period of time, it is called as a continuous spillage. And if it is a one-time release, we can say that it's an instantaneous spill. After that, you need to select the region of the spill, either Indian Ocean, Gulf of Kutch, or Gulf of Khambat. If you are not sure about the region of the spill, you can select the region of Indian Ocean, and you can give the necessary information here, the start date and end date, and you need to give this geographical information in decimal degrees. If you don't know in decimal degrees, you can convert your inputs into decimal degrees. Here actually an DMS and DD converter is there. By clicking on this one, you can enter your DMS coordinates that will get converted into DD, that is decimal degrees. And then you need to select the type of the pollutant, and you need to enter the quantity, how much quantity is filled, and the unit also you need to enter, that is here metric tons. So once after submission, you will be getting a result page like this. It will tell about what is its spill type, means whatever you have submitted, it will reflect here, and it will also tell the model has completely finished its run without any error. And in this result page, you can see the start position, and what is the pollutant you have selected, and how much quantity is released, and how much what is the duration of this trajectory prediction. So everything will be getting here. These are all some typical examples which were generated yesterday. Here you can see, once after the simulation, you can see this is the initial spill location, and these red dots are showing the position of the particles. By clicking on this dots, you can, by clicking on this dot, you can get the spatio-temporal information. Here you'll be getting this date and time, and the geographical location also. This is as far as an instantaneous spill is concerned. In an instantaneous spill, since it's a one-time release, you can notice there won't be any connection with the source. So the pollutant has been detached from the source. And here, right side, you can see there are several layers are there. If you click on the particular layer, then it will display the pollutants after 3 hours or 6 hours, and after 12 hours. So you can select the particular layer, and it will give you the pattern. Here you can see this is an execution from the continuous spill, and again it's an hypothetical spill only. Just for the demonstration purpose, I have generated. Here you can see the pollutants, the pattern here, and again by clicking on a particular plot, you will come to know the spatio-temporal information, like what is the date and time and what is the geographical location of it. So as far as the version 3 is concerned, simple, it's a simple operation as far as the version 3 is concerned. And now we are, as I said earlier, we are working towards the version 4, which is an advanced version. Here, we are using a specific WebGIS platform. So with the help of that, the user can interpret the data also. So by selecting a particular, by clicking on a particular dot, the user can know what is the status of the pollutant, whether it is evaporated or whether it is beached or whether it is still floating. So all this information will be included in our forthcoming version 4, so that the user can decide based on his requirement. The user can also interpret with the help of this version 4, so that by clicking on several layers, and he can enable different layers, and then they can take a decision of their own. So now I have come to the end of the session. I would like to thank you all, especially all the officials of Indian Coast Guard of Northwest Region. I especially thank Commandant R.K. Srivatsava and his team for gathering all the participants and making this a training session a valuable one. Unfortunately, due to some technical issues, we couldn't able to rectify some glitches. Otherwise, I hope this was an useful session. If you have further queries, or if you face any difficulties in the oil spill trajectory prediction using your system, you can always contact us, or you can always write to me, so that I can rectify all the issues. I would like to thank our Director INCOIS for permitting this online course, and I thank my group head, our senior scientist, Dr. Balakrishnan, also for supporting supporting this modeling activity. I'm thankful to the head of the Department of Training and Planning group, Dr. Uday Bhaskar, who was very much who was very much with us in organizing all these activities as far as this online training is concerned. And I am thankful to my colleague, Mr. Kiran Kumar, who is behind this RGIS system, who has done exclusively in representing the drift patterns in the WebGIS, sophisticated WebGIS platform. Soon we'll be operationalizing that version 4. And I thank my colleague friend, Mr. Satish Kumar and Kavi Arago, also for supporting me in doing this online. I thank you all once again. So now it is opened for the discussion. We can discuss, like if you have any specific queries.
Several units at Porbandar, Okha, if they have some questions, they can ask the questions now, please. Finally, the Gandhinagar will be clarifying certain queries. Okha, Porbandar, you can unmute yourself if you feel like. फोन करके पूछो वो फोन करके पूछ रहे तो हमको व्हाट्सएप कर देना, हम यहाँ से पूछ लेंगे उनके क्वेश्चंस। क्या पता है नाम इनका? गुड इवनिंग डॉक्टर प्रसाद।
Yes, sir.
Good evening, I am Commandant Ahuja. It's a lovely witnessed with a lot of professional in-depth in the presentation. I'm very happy to see this presentation and the new version which is coming up, the USA 4 version 4. I'm sure that will be much more detailed and in-depth data will be provided for our decision making at headquarters. I have got 2-3 questions. One, as you said, the registration, because this registration would be done by any agency, either government or non-government also. Is it a paid or non-government?
No, it's free for everyone.
Okay, fine. Second question, you have shown the trajectory to be determined based on the wind pattern and the current. Is there any option of the trajectory projection based on the density of the oil?
Yes, density actually plays a vital role here, because whenever you are selecting the type of the pollutant, it plays a vital role. For example, I can compare, one is the diesel oil, the other one is the fuel oil. The diesel oil, it will be comparatively, it will have the lesser density when compared to the fuel oil. So the density plays a vital role, as you rightly pointed out. And moreover, as far as the three-dimensional modeling is concerned, the density of the oil pollutant plays a vital role. If the density increases over a period of time, the oil particles will sink in the water column, and there is a probability of sedimentation also. So the density plays a vital role, and here, as far as weathering is concerned, the density is a vital parameter.
That's right.
And of course,
My
this
question is,
density is taken into consideration while simulating the drift pattern.
my point is that only, because you have written, you have shown that you have to select the pollutant. But
Yes.
is there any option for selecting the density of the oil? Because if we know the tanker was having so and so fuel, let's say X category, and by the record we know that the density of that oil was so much. So can we put that density option and select the density and then define the trajectory pattern?
Basically, we want to ask you, Dr. Prashant, whether is there any pre-fed data available as far as the density of various oils like Iranian crude or the Brazilian crude or something is there. So have you pre-fed the data about the density and other parameters, other physical parameters in the system?
No, as far as the trajectory prediction is concerned, there are predefined 5 categories of pollutants.
Okay.
Like the bunker type and the diesel oil, and then the
Okay.
jet fuels. There are only 5 categories here.
Okay.
And as you said, if you want to feed the density of the particular pollutant, you need to go for a sophisticated model. So
Okay.
I have shown you a three-dimensional simulation also. In that
Okay.
one, there is an option to feed.
Okay.
There is an option to feed the density of the particular fraction also. Suppose if you consider an oil pollutant, it will have the heavy mass fraction, it will have the volatile mass fraction, it will have the wax mass fraction. Several fractions will be there. So what
So
you
it
need to do
means,
is,
it means the user will be able to feed them. Registered users will be able to feed all these physical parameters. What you are talking about?
no, right now the user, there is no option to feed that density parameters here. Because if you go for a three-dimensional modeling, then you can do that. That too, once after an operationalization of our three-dimensional service, you can do that. But right now, as far as the 2D modeling is concerned, the
Okay.
density is kept apart.
Okay.
And
Okay.
one more information, only you can predict the pattern of the mostly reported pollutant like fuel oil, bunker type oil. That information is already preferred into a system, so you can select that particular pollutant and you can generate the drift pattern.
Now, Dr. Prasad,
Yes.
as you know that in Indian coast, there are various ports handling different kinds of oil.
Yes.
This model which you have developed, have you taken the statistics of the various like Khambat or the Kutch, what kind of oil is being imported or exported, so that you have actual data available pre-fed in your system?
No, that one we'll be getting from Coast Guard only, because we are once after getting the report of oil spill, we are taking that pollutant and we are feeding that into our model, and it will generate the drift pattern. But as you said, there are several categories of oils are there based on their density, and for that a separate library has to be developed.
Correct.
So later
My point
we
is
can,
that
yeah.
we'll get an actual picture because we know that the fixed trade is being happening in Kutch or Khambat, the kind of oil which is imported or exported. If you have this data available and if you feed it, we can select that option, and then that will help us to actually get a correct trajectory pattern.
Yes, sir, you're right. But as far as that one is concerned, we are working on another three-dimensional Python-based model is there.
Okay.
So, but it will take some time to get launched.
Now, my second question, Dr. Prasad, as you said about the trajectory on the surface, but what about the movements of surface? As you said, sedimentation all takes place in the weathering, the globules develop, they settle in the seabed. So, does this model give you that prediction also?
In the 3D model, it will give that characteristics also, like how much mass is sedimented and how much mass is suspended. Also, you can see that. So all those characteristics will be considered in the three-dimensional modeling, not in the two-dimensional modeling.
Okay. Now, third question. As you know, when we deal with this oil spill, we have to use certain chemicals, which is oil spill dispersant. And as per NOS TCP, National Oil Spill Disaster Contingency Plan, which is promulgated by Indian Coast Guard, there are few categories of accepted OSDs which has got the role to play in dissipating the spill. So, can this model think about that, and how will this chemical behave, and what is the quantity of chemical required in this model itself?
No, right now this feature is not available in this model.
No, I am suggesting for future.
In the future we can do this. Future we can do.
If we give you the details of the OSD and the proportion in which it has to be used based on the type of this spill which is there, this can give a suggestion. It cannot be a dictation, but it can be a suggestion from the model giving to the user that suggest would use this for the dissipating of the oil.
Right now it is not that, but in future it is possible.
Okay, Dr. Prasad, one more thing. Like you said that since the physical characteristics of the oil and chemical characteristics of the oils are not fed into the system as of now.
Yes.
So is there any possibility, if there is any actual oil spill happening, and if we send you certain characteristics as per your requirement, then you can work it out and give us the feedback?
Yes, we can do that. Whether you need the two-dimensional modeling or the three-dimensional modeling.
Okay. So as a case-to-case basis, in case we require it, so it can be done, is it?
Yes.
Okay, so how much time generally it takes for carrying out the analysis and giving us the report?
As far as this three-dimensional modeling is concerned, we have to run the model several times.
Okay.
So after that, we can, after once getting a confidence on that, then we can give you that particular information.
No, that's okay. The way you have calculated certain, the area of the oil spill for the empty diamond, same way if something happens, will you be able to help us out on that? That how much if we want to quantify the oil spill, how much it is? So will you be able to help us out in any case?
Yeah, sure. We can quantify and we can give that to you. Suppose if you are telling a particular quantity of pollutants, suppose 500 metric tons or 1000 metric tons.
Okay.
Based on the simulation, we can compute how much will be evaporated and how much will be beached and how much will be floating.
Okay, so what is the initial data requirement for you to calculate these things? Can we have a format or something that if we need this kind of information from you, being Coast Guard at Northwest, so is there any format can be made by you wherein which you can say that yes, you tell us what is the area covered by the oil spill, something like that, and then we can give you and then you can calculate and give it to us?
The format, as far as only you can give the preliminary information, like as I told earlier in the presentation, you need to give us the geographical location of the spill, and
Yeah.
then how much quantity is spilled and what is the type of the pollutant.
So how much quantity I am not able to do? I need to do some calculations physically, which is available as per the certain formula. But if same thing can be done online, or on the computer-based model, so that will be more accurate. That is what is my question. Or you have any software wherein which we can actually get into this, or we can get it from you officially, and then we can do ourselves.
Right now, there is no software for computing the quantity of the pollutant based on the area of the spill. But one
Okay.
suggestion I can give,
Okay.
based on the data which are obtained from the radar sensors,
Okay.
in the radar sensors, it will be giving the area of the coverage.
Okay.
From the area of the coverage, if you know the density, you can find out the quantity of the pollutant spilled. That is
Okay.
possible. It is something like a reverse calculation.
Yes, yes, those formulas are there. That we also do. Even when we carry out the aerial survey also, we actually try to physically measure the spread of the oil, and then we calculate that.
You know, what you said is right. You know, this is a challenge for the responders and the modelers. You know,
Okay.
Actually for our modeling, we need the exact quantity.
Okay, fine.
Because, you know, based on the quantity, the weathering characteristics will vary. And, you know, if you don't have the right quantity, we cannot be able to estimate the quantitative status, like how much is floating and how much is evaporated.
That is what is my question. When we,
Yes. Yes.
So we know that how much oil spill is going, what is the spread of the oil is going to be. And if we know the exact characteristics of the oil, whether it is, suppose take it as an Iranian crude oil, so we know certain things, that what is the density, what is the flash point, what is all those things are available with us, suppose, as a standard.
Yes, yes.
So if we give you that, this much oil probably has spilled out from a ship, and
Yes.
then what will be, and it has spread to a certain area, so then how much actually the emulsification and those things have taken place? Can we do something on modeling based study on this?
Yes, we can do that. We have to use the three-dimensional model for this. I hope you are aware of this Mic 3 model. So you
Okay.
can, right now I am using that model. If you have that
Okay.
particular information, then with the help of this three-dimensional model, we can give that.
Okay, perfect.
All the weathering
Thank you.
characteristics we can give.
Okay, Dr. Bhaskar, I go on. Dr. Prasad, sorry.
Yes.
I have another, sorry, I am giving you some suggestions which you can think of in the new model, which is recently we had a discussion with the forest department, and wherein they told that in various locations, the ecological sensitive area has been marked, there is a reserved area because of the flora and the fauna.
Marine national park.
Marine national parks are there. They are sensitive area, and the ecological sensitive areas are there. Can this also be mapped in your new version so that it helps? Because how serious is if the spill is moving towards this area, then the reaction has to be faster.
Yes, it can be done. If you have that specific information in a particular format, like I have shown the coastal geomorphology. So these eco-sensitive zones can be included into our system, and we can generate the drift pattern, and the users, if they find more useful to take the decision.
Correct. So we will share with you. Kamal
Yes.
Srivastav has been handling all this, so I'm sure that he would share with you through forest department.
Dr. Prasad,
Yes.
my question is a little different from my two seniors. They have covered all the Coast Guard requirement of oil pollution. I'm skeptical also whether my question falls in your domain expertise, but however, I'll ask you.
Yeah, please.
Now, sir, apart from all this oil pollution, so much of pollution is being thrown. There are many flavors of pollution to the sea. You see the urban pollution which is being thrown into the sea. So, do you have any mechanism how to monitor the sea? The incidents happening at the sea are probably in 2 years or probably they're not very recurrent. Where is the pollution which is being thrown into the sea? It is probably more than what we see in the accidents in terms of oil pollution. So do you have anything, how we monitor this, how we check this? Do you have any methodology to, inform the government that you have to take a check on this also?
He's asking you for remote sensing. Do you have anything as of now available? Any satellite service available at your disposal, wherein which we can actually cover the EEZ area or the air surveillance part of it?
So that doesn't
I got your question. There are satellites available, radar missions are available, which you can employ themselves for your study. But only thing is, the pass of that satellite will not be continuous, and it will not be for your desired region of study. We have discussed these things with the ONGC also during our earlier research period.
we have also suggested some other network of radar missions also. So what you can do is you can use different radar missions. For example, you can use Sentinel-1 and you can use NVSAT. You can use other radar missions, so that you need to monitor manually when these satellites are coming to your region of study. And then later you have to collect, you have to get the acquisition plan, and after that, if the passes are available as per your convenience, then you can do the monitoring. But only the disadvantage is you cannot continuously monitor a particular location.
Yes, affirmative. Yeah, thank you, sir.
Dr. Prasad, sorry, last question.
Yes.
Little innovative. As you know, we have got various vessels coming to the Indian ports, and they are permitted to dump fuel prior entering into the territorial waters, and there are certain permissible limits in which they are allowed to dump. And due to the propulsion system and all this, there are certain spillage also happening. The overboard discharges are there, all these things are there. There are some certain permissible limits. So considering these permissible limits on various discharges, have you thought about that in the sea lanes of communication which is there? All the merchant ships, plying from the EEZ of India. How this pollution is going to affect overall the oceans? Is there any study done?
No, as of now, I guess such study was not carried out so far.
Yeah. Okay. So you can think about, because you are into such a location where your scientists can think about this larger perspective.
Yeah.
Thank you so much.
Okay, thank you, Dr. Prashad and your team. Thank you very much for sparing your valuable time for us. I understand the upgradation is taking place in your system. And I am thankful to Dr. Balakrishnan also and you both that you have slotted time for us, for training us. And I'm sure about it that there is lots of room available for studying your software as well as our parameters available with us. And in future, I hope we gel with each other in a better manner for the ecological balancing of the area. That is what I can say. With that note, I finish. Anything else from you? Thank you very much once again.
Thank you all for your kind attention. I have taken all your feedbacks so that we can include that in our research and modeling study. And whatever we discussed, they are quite research oriented and they are quite operational oriented. And with our future collaborations also, we can do this as far as in the research and operational mode. And certainly we'll be happy to guide you, and we'll be happy to collaborate with you, and we can enhance our modeling and operational activity through and sustained research.
Okay. Thank you very much, Dr. Prashad and team. Thank you very much.
Thank you all.
We can go all the way. Thank you. Thank you very much.
Thank you all. Good day.
Good show.